Well, greetings, Mr. Kolazar's class. We're going to start looking into the periodic table. Now remember, a lot of times we're going to look at the PT periodic table is how it's going to be abbreviated. So you'll see that all the time as we're going. But as we start into Chapter 6, Periodic Table and the Periodic Law, it started out about the 1700s and 1800s as we were starting to push into that Industrial Revolution. Science has been really on the increase. It brought a lot of new information about, a lot of new science and information, and we started to discover a lot of new elements. And as we got so many elements discovered, we started to need a necessary way to organize or create an organization pattern and strategy for all these elements. And so as we started to look, a few people were involved in the beginning of this process. John Newlands came up with the idea, first off, the law of octaves. An oct or octaves, the number 8, is going to be a very important number for us. In 1864, he looked at the idea that elements, when they're arranged by increasing atomic mass, that about every 8th element repeated chemical properties. So like lithium and sodium, similar properties, and that continued on for potassium. And then, as we went further down, they had some different names. Boron is where we have now, and magnesium had beryllium and magnesium had similar. They changed this later on. Magnesium, boron, and aluminum similar, carbon and silicon similar, nitrogen and phosphorus similar, oxygen and sulfur, all similar with every 8th element. So it's kind of a repeating pattern they've begun to see. Dmitri Mendeleev, the man, the myth, the legend here, Dmitri Mendeleev came up with the idea in about 1869 to organize the first periodic table. And this is an actual picture of the first periodic table as he organized it. And what he did was actually charted out or played them all together. And it was based on the atomic mass and their similar chemical properties. And so he just took it a step further and actually created a chart. And he's credited with making that first periodic table. So Dmitri Mendeleev, our periodic table now, the biggest difference between it is that it's arranged from left to right instead of up and down. So very similar. Now, where he got so much credit was the fact that he predicted the existence and properties of certain elements that were undiscovered. So he actually left blank spaces in his periodic table, thinking that at some point elements would be discovered that hadn't been yet. And that was an interesting idea because scientists thought that all the elements had been discovered, and Dmitri actually left blank spaces in his periodic table saying that if we were to find this element at some point later on when science can catch up to it, that it would have similar properties. And the properties he predicted were very good predictions. He was very close on the density and the reactivity and many of the things about like what they would look like and everything. So it was pretty amazing science-wise there. So Dmitri, father of our periodic table. Now, there were some problems. When you look at your periodic table, when you look at like the elements cobalt and nickel, cobalt, 58.9 is its atomic mass, mass number, and nickel, 58.7. So it actually decreases from one to the next. Another one, tellurium to iodine. When you look at 128 to 127, they don't quite match up the way they should. And so those were flipped around originally. Henry Moseley came around, and in 1913, he modified the periodic table into its modern form. And it's based on increasing atomic number. Remember, number of protons. So the way we see the periodic table today is by atomic number: 1 proton, 2, 3, 4, and then in our groups or columns that have similar chemical properties. And so that's the version that we see today is by the number of protons, not the mass number. And so X-ray diffraction is what he was using there. Last thing, periodic law. If you periodically do something, it means you do it over and repeat it. And so the periodic law is the repetition of chemical and physical properties of the elements when they are arranged in increasing atomic number. And so kind of every 8th element had that repeating pattern. So periodically those elements would repeat patterns, and that's where we get the idea of the PT or the periodic table from. That'll end our first section.